purpose of this video is to guide you through the first part of the onboarding process. So you should have already read through this PDF that details what we're going to be doing here. So make sure you've done that first. Otherwise, first thing you need to do is open up a new let's see. Yeah, there you go. Simulink model from the home menu there. I'm going to create a blank model. Then open up onboarding as well. Just copy paste that over here. Like so. Then you want to highlight all of this. There's like this little 3 tilde, create subsystem. I'm control Z there. Because I accidentally, I didn't want that. And then you can just make it bigger. Align the signals. Then we actually get to making a controller. So you can create a blank subsystem by just dragging on an open area, clicking the subsystem button there. And so this controller, and then we can do Control R to rotate. This controller took in 2 inputs and some parameters. In this simulation, those inputs come from this signal here called digital signals. And I just deleted that by clicking the delete button. And then the output is going to be all 3 of these. Now, in the document, I only stipulated 2 outputs. Now, this third one here, brake pedal, I'm just going to set it to 0, but technically it is another control action that is part of the vehicle. So there you go, and then we can click on the subsystem and rename it to controller. Likewise, this one can be renamed to plant. Very well. Then we can go into this subsystem here. We can start designing this, or really just implementing the controller we've already designed. First thing here we can do is so I'm double clicking here, to get this search bar open up, and basically you just type in the block name that you're looking for. What I'm looking for is a bus selector. This signal right here is a bus. The way you can tell that, well, I guess you can't at the moment, but once you've compiled this thing once, this signal will look different. So now we can just connect that, make it a little bigger, then extract the signals that we were looking for. If you double click this in here, you can move those, and then the first one, so I think it's better to use analog signals. In fact, they both output pretty much the same data, but analog signals are just a bit more accurate. So here I'm going to look for a terminator just to end this signal. So now instead of digital, we're going to have analog signals here. And when you double click this, you'll actually see a different set of elements, because I'm looking at a different signal here now. So what we're looking for is your displacement and your velocity. Displacement being x and velocity being v. Now we also have to extract omega, which is the wheel speeds, angular velocity of your motor shafts there. That's not related to this controller. It's just how this simulation is set up. Alright, so the next thing is to compute the values that we were looking for. Notably, we're looking for the norm of the velocity. So that is the dot product of the vector with itself, and then you take the square root of that, and that is the norm. And then just realized that I've made a mistake here. I want to extract the velocity, and you see, there you go. I'm computing this from velocity, so that's good. And then for position here, we were only wanting to select the second element. So if we go into here, double clicking, and we put in 2, we're selecting the second element. Displacement here is x, y, and z, and if you recall the coordinate system, y is the lateral direction. We want to control the lateral displacement, and therefore we select the second element. Now the next thing we can do is define the reference that we want here. So for displacement, we always want the displacement to be 0. The vehicle starts at the origin 0, 0, 0. Therefore, the second element y is 0, and we want it to stay that way. Now I'm just implementing that formula. I believe number 4. We get a sum here. And modify this to be, I think, something like that. Got it wrong. It's minus plus that. No, I actually did get it right the first time. You're adding your reference, subtracting the true value, and then you get a gain. And that's your P2 in this case, if you're going by the formula. And the final step I mentioned was a saturation. Your signal should be between some upper and lower bound. And that's U2 computed. U2 is, of course, just the steering angle. So we can just basically do the exact same thing for the velocity. Get a sum. In this case, it should be minus plus. Of course, I did get it wrong. And then I realized that I didn't. Subtracting your actual, and in this case, the reference, well, it could be any number, any velocity that you could achieve. I'm just going to set it to be 10. The units here are meters per second. So I'm saying I want the vehicle to be traveling at 10 meters per second here. And then likewise, I can get a gain. If you just select and Control C, you can copy. That's what I was doing there. Then likewise with the saturation as well. And that is the torque command. Now, there is one thing to note here. So for steering angle, this is a scalar. There is just one single number. And that's the end of this recording.